A few more review questions from chapter 16. So first one, what we want to do is we want to show that this is conservative vector field, and then we want to find the originating potential function f. So how are we going to do this one? For the first component, we want to see, if this one wants to be conservative, I'm going to take the derivative of this expression against y, and then I'm going to take the derivative of this one against x, and then to see if they're equal to each other. Because we are assuming that this must be, if this one is f sub x, and if this is f sub y, if this one wants to be the gradient vector field, then what I'm going to do is I'm going to figure out f of xy by taking the derivative of this one against y. Then what do we end up getting, guys? We're going to get the product rule here. So I'm going to take the derivative of this one against y. So what do I get? I'm left with x. By keeping e to the xy as it is. Plus, I'm going to take the derivative of this one against y. That means x e to the xy. Well, I have 1 plus xy. So then when I combine them together, what do I end up getting? So when I multiply these two, these are the same thing as this one. So we get 2x e to the xy. And the second one is plus x squared y e to the xy. So that's what I'm getting for the first value. Let's look at the second one by any chance. So if I were to try to get the second one, what we end up getting is, I'm going to take the derivative of this one against x. So that means this one simply disappears. And then how about here? I would have gotten derivative of this one by getting the product rule. So first derivative of x squared becomes 2x times e to the xy, which is perfect. And then second one, take the derivative of this one against x. That means y would have come to the front. So x squared y and e to the xy. So this in fact is equal to f of yx. Since they are the same, we know that this is conservative. Since it's conservative vector field, let's try to find the potential function. So now what I'm going to do is, if this one were to be the partial derivative against x, then what I'm going to do is I'm going to integrate this one against x. 1 plus x y times e to the xy dx. So I'm going to take the derivative integral against x. So then for the first one, I'm going to rewrite this one as e to the xy by distributing this term plus xy e to the xy dx. As you can see, for the first component, when I take the integral against x, then what I end up getting is e to the xy and then over y. That's what I would have had. On the other hand, for the second one, I have to use the partial bipartite. So then I'm going to look at this one because I'm going to assume that y was already there. X e to the xy dx. So then I'm going to set u and then dv, v. So I'm going to assume that u was x, then du equals dx. dv is equal to e to the xy. Then v must be equal to e to the xy over y. So what I'm end up getting is I'm going to get these two things multiplied together. So x e to the xy over y, and then I have to get the minus integral of the e to the xy over y dx. Then what would have happened here is that this y would cancel away with this one. So I'm left with x e to the xy. So plus x e to the xy. when you take the integral of this one, another y would have gone to the denominator, but y will cancel away. So we have minus e to the xy over y, and then not plus c, but plus function, let me call it g of y, including the constant here. So what you end up getting would have been these two things cancels away. Oops. Let me just... Then these two things cancel away. So far, our potential function would have been x e to the xy, and then plus g of y. So let's try to find the other component. So I'm gonna look at this one, and then I'm gonna take the integral against y. My function was f of y was e to the y plus x squared e to the xy dy. Now, then first one is rather simple, which is simply e to the y. Second one becomes x would have been going in as a denominator, which cancels out with one of the x, so with plus x e to the xy and plus h of x. So I have to compare this answer and then this answer, and you can see that these two terms match. And I noticed that I suppose that I could have g of y, and then that g of y would have been this one. And then how about h of x? I don't see any matching, so therefore h of x would have been equal to simply a constant, rather, because there could have been still constant, which would have cancelled away in either way. So therefore we realize that the potential function f of xy must be equal to e to the y plus x e to the xy plus c. That would have been the potential function. Alrighty, let's move on to the next problem. Number 13. Show that f is conservative, so we're going to take the mixed partial and then set them to be equal to each other to see if that's true or not. And then we will be evaluate this one, the line integral. So first, let's see if the mixed derivative will be in fact equal to each other or not. So we're going to have, this one is what's f of xy. I'm going to take the derivative of this one against y. Then 2 comes to the front, so 8x cubed y, and here minus 6xy squared. Now what I'm going to do is from here I'm going to take the integral against x. Then what is f of yx? So 4 goes to the front, so we have 8x cubed y, and then 2 goes to the front, minus 6x, and then y squared, and then the last term becomes 0. So good, it is conservative. Then we need to figure out the integral, because f dot dr is in fact equal to if you know the potential function, we can just put it this way anyway. So what we want to do is we want to find out the potential function. What will be the potential function? I'm going to take this one and then integrate it against x. So 4x cubed y squared minus 2xy cubed dx. So what do we end up getting, guys? That's equal to, actually we don't have 4. We just have x to the 4th power y squared, and then here minus x squared y cubed plus g of y. Now I'm going to do the same thing with the other one. I'm going to take the integral of 2x to the 4th y minus 3x squared y squared plus 4y cubed dy. Then my first one in this case becomes x to the 4th y squared and minus x squared y to the 3rd by looking at the second one. The last one is plus y to the 4th plus h of x. And you can see that these two terms match. And of course, y to the 4th power must be coming from g of y, and h of x doesn't match at all. So therefore, we realize that our original potential function f must be x to the 4th y squared minus x squared y cubed plus y to the 4th power. Now, then what are the points? We realize that t goes from 0 to 1 when t is equal to 0. What's the value of x and what's the value of y? Let's look at it. When t is equal to 0, this is equal to 0. And this is equal to sine of pi. What's sine of pi? That's also equal to 0. So when t is equal to 0, x component is equal to 0. And y component, this one becomes 0 and then this one becomes 1. So we get 0, 1 is the first starting point. And when t is equal to 1, what do we end up getting, guys? When you plug in 1 here, this one is 1, while sine of pi is equal to 0, in fact. So what we end up getting is 1. Second one here, this becomes 2, and then cosine of pi becomes negative 1. So 2 minus 1 becomes 1. So what we end up getting here is starting point is 0, 0, 1, and then 1, 1. So what we end up getting is, to evaluate the line integral, what we have to do is f of 1, 1 minus f of 0, 1. But what is f of 1, 1? On this function is simply add up the coefficients. So 1 minus 1 plus 1, which becomes 1. Second one is when x equals to 0, this 0, this one becomes 0. Only thing that's left is y to the 4th power. When you plug in 1, we get 1, so we get 0. So therefore, our answer becomes 0 for this case. Alrighty, let's move on to the next problem, number 15. So number 15, they want us to verify that Green's theorem is true. That means what we want to do is we want to get the line integral is in fact equal to the double integral surrounded by that or enclosed by that line integral. So then let's try to sketch this one for a second. Y equals x squared. So how does the y equals x squared looks like? So imagine if I have, this is x-axis and this is y-axis. So you can assume that y equals x squared from negative 1, 1 to positive 1, 1. So I'm going to say it's going to be something like this. So this is a starting point and then that's the ending point. And then line segment from here, 1, 1, 2. So we're just going to go straight down this way. So first path is parabolic, second path is a straight line. Now, then let's try to look at that one first. I'm going to call this one the first one. This one is the second one. How would you be able to describe the first path? Yeah, x r sub 1. Let me just call that as a first path. I'm going to say just t. And then y value is t squared. So basically I'm just copying this one, where t goes from negative 1 to positive 1. So essentially that's what we end up doing. And then, so then what do we end up getting, guys? Our path becomes, so here, negative 1 to the 1, xy squared. So then this one squared, so we get t to the 4th power, so t to the 5th power. And dx equals simply 1, so that's done. Minus here, t squared times t becomes t to the 4th power. But dy is 2t. So we get 2t to the 5th power dt. That's what we end up getting. So what we end up, so if you have to continue, then this one now becomes simply for the first path right over here. Then from -1 to 1, we get negative t to the 5th power dt. Then if you have to continue on this one, so we get negative t to the 6th power over 6, -1 and +1. One thing is when you plug in 1 or when you plug in -1, both of them will be equal to 0 anyway. I mean the same value, so our answer will be equal to 0. Let's go for the second path. Second path is, you can see the y value is always equal to 1. Y is equal to 1. But x has to go from 1 to -1 on the same interval, let's call it. Then I can call that as negative t. Then when t is equal to -1, I'm at 1, 1. When t is equal to 1, then I'm at -1. So that's basically what we can say. All right. So then what do we end up getting, guys? So our integral, y value is 1, hence dy will be equal to 0. So I'll be just looking at the first component here. So x is negative t. And then y is 1, so and then dx equals -1, so we get positive dt. That goes from -1 to the +1. Then we get t squared over 2, -1 to 1, we get 0. So overall, everything becomes 0. That's about the, that's based on the line integral. Now, but let's try to go for the double integral. Now, what I need to do is, in order for me to do that, I need to take the derivative of this one against x, and then I need to take the derivative of this one against y. So I'm gonna take the derivative of this one against x. So what do I end up getting, guys? Then I'm gonna be getting negative 2xy. And then here I'm gonna take the derivative against y, then minus 2xy as well, one more time. And then dA, which now becomes -4 xy, and then we can go for dy dx. Y top is equal to 1, bottom is equal to x squared. And then xy, I'm going to go from -1 to the +1. So then I already have -4. When you integrate this one against y, then we get xy squared over 2. That goes from x squared to 1 dx. So when you plug in the 1, and let me just bring 1/2 out, so we have -2, -1 to the +1. So then what we end up getting is when I plug in 1 in place of y, so we get x minus, and then when you plug in x squared, here we get the x to the 4th power, so x to the 5th power, and then dx. When you integrate this one, we get -2 x squared over 2 minus x to the 6th over 6. That goes from -1 to 1. So whether you plug in 1 because of the even exponent, when you plug in -1, they will be the same value. Hence, we get 0 as the answer. So you can see that it was the same answer in both ways. And we realized that. Then I guess we just verify that Green's theorem works for this question. Alrighty, let's move on to the next question then. Number 17. They want us to actually use the Green's theorem to evaluate this one. Since it's counterclockwise, it's going to be positive orientation. So what I'm going to do is I'm going to take the derivative of this one against x. then what I end up getting is I'll be getting negative y squared. And then this one against y, then minus x squared dA. But when you look at the dA, this one is essentially the polar, function. So what I'm going to do is I'm going to factor negative sign out, and then it was simply one circle. So what I can say is this one is equal to r squared, and with another r's we get r cubed dr dt, and dr d theta. So r goes from 0 through 2, and theta goes from 0 through 2 pi. So we could have negative 2 pi multiplying together, and then the other one is here r to the 4th power over 4, 0 through 2. When you plug in 2, you get 16, so we get minus 8 pi. When you plug in 0, it becomes 0, so minus 8 pi becomes our final answer. Alright, and I'll see you later.